Welcome to this video on the topic of trigonometry. In this video, we're going to have a look at how we can calculate unknown side lengths within right-angled triangles. However, for this video, we're going to have a look at some slightly more vexing problems. Over here, we have a right-angled triangle. We're given a known angle and a known side length. However, we don't know the value of x, nor do we know the value of y. Now, to solve these values, what we're first going to do is start off by labeling the quantities that we're given in the triangle. So we have theta, we have the opposite, we have the hypotenuse, and finally, we have the adjacent side. Now, as always, we're going to list all the values that we have. Alright, so I've got a value of theta of 15.7 degrees, an opposite side which is equal to 18 micrometers. Then we have A is unknown, set to y, and the hypotenuse is set to the unknown x. Now to start off with, we're going to first calculate the unknown value for A, or the adjacent, which is y. To do this, we're going to use theta and the opposite because they're known values. So we'll say for y, and because we're using the opposite and the adjacent, we're going to use tangent. Writing out the ratio, subbing in the values. And it's at this point where we realize the difference between the examples we were doing in the last video and the examples that we do in this video. What you can see is that the unknown is in the denominator of the fraction, or it's downstairs. And to be honest, we don't really want it downstairs because it makes it more difficult to work with. Now, the way in which we make y the subject is we have to do two steps instead of one step. The first step we're going to do is we're going to multiply both sides of the equation by y. This is going to yield y tan 15.7 degrees is equal to 18. And of course, we don't want y tan, rather we want to know what is the value of y. So I'm going to remove tangent by dividing both sides of the equation by tan 15.7 degrees. Just like that. This is going to yield a result of y equals 18 over tangent of 15.7 degrees. And thus we successfully rearrange the equation such that y becomes the subject. So notice the two extra steps here. We multiply by y and then we divide by tangent. Now there's other ways to make y the subject, but I recommend following this just for now. Alright, evaluating the value of y, we bring our calculators up and we plug in the values. So I'm going to go 18 divided by tan, and using parentheses, 15.7 degrees. I hit execute. This gives us a value of 64.037, or to two decimal places, 64.04. The units, of course, being micrometers. And we went to two decimal places, thus coming to the first result. Now the next quantity we're going to calculate is going to be the hypotenuse. Now what we have is the opposite, the hypotenuse, and theta, so we're going to use sine. Writing out the sine ratio, and then subbing in the values. Notice how easy it is to make a mistake with this. Rearranging, we're going to multiply by x and subsequently divide by the sine. Therefore, we come to the expression that x is equal to 18 over sine of 15.7 degrees. Bringing up the calculator to evaluate this expression, we get a result of 66.518 or 66.52 micrometers. So notice the difference in form that we're working with here. In the previous examples, all we need to do is multiply by the quantity in the denominator, but because in this case the quantity is unknown, we first have to multiply and then we have to divide by the quantity on the left to make the unknown the subject. So it's a two-step problem here. Alright, refining our skills, we turn our attention to the final problem. We have something that's a little bit nuanced. We have a regular triangle, which we can annotate. So we have theta, our angle of interest. The opposite, we don't really care about. The adjacent is over here, and the hypotenuse is where the action is all at. we have an expression for our hypotenuse, z minus 5. Now you might feel a little bit alarmed when you see an expression like this, but basically we're just going to treat it as if it's just a regular number, just like before. So listing all the values, there's no need to put down the opposite because we don't need it. We have 10 kilograms for this triangle, something a little bit new as well. And then we have z minus 5 for the length of our hypotenuse. Now looking at the quantities we have theta, the adjacent, and the hypotenuse. So what this tells us is that we need to use cosine. So solving for z, we're using cosine. And then I sub in the values of 10 kilograms all over z minus 5. I'm going to keep the brackets there for now. Alright, so what you can see is that the unknown is at the bottom again. So to sort this out, we multiply both sides by the quantity in the denominator. Notice I'm multiplying through by the entire bracket. I'm not just going to do z because that will give us an erroneous result. So on the right we get 10, and on the left we get z minus 5 in the parentheses, followed by the cosine of 50 degrees. And then to isolate z minus 5, we divide through by cosine of 50 degrees. This will yield a result of z minus 5 on the left, and then on the right we're going to get 10 over cosine of 50 degrees. Now I might be tempted to throw this in my calculator, but remember we don't really care about what z or z minus 5 is, we care about what z is. So what we're going to do is we're going to crack open these parentheses by pretty much doing nothing, and we simply add 5 to both sides of the equation. The reason we add is because this is a subtract here, so if you want to get rid of the minus 5, you simply just give it 5. Therefore we're going to get 10 over cosine of 50 degrees plus 5. If 5 doesn't go up top here, it stays to the side. Alright, now it's time to whip out the calculators. Keying in the expression on the right, we're going to get 10 over cosine of 50 degrees. Use the little D-pad here to shuffle to the right, then I go plus 5, and thus we come to the conclusion that the result, or the unknown side length, or the unknown quantity I should say of z, is, and thus we come to the conclusion that the unknown value, that is z, is equal to 20.56 kilograms, not a unit of distance, rather a unit of mass. So in conclusion, in this video we demonstrated how we calculate unknown quantities within a right-angled triangle when we find that the unknown ends up in the denominator of the equation we define using the trigonometric ratio and functions.